Let's go ahead and get started with the roadmap discussion. And Harry, I guess I'll turn it over to you and you can kick it off and let me know if you need to scroll anything.
Two things, because I see people are still joining for the roadmap discussion, to buy just a little bit more time. So I'm going to update, just so everybody's aware, I'm going to be updating the Zoom URL, because going forward we have to have a passcode built into the Zoom URL. So I just want to make sure everybody is aware, probably in the next few meetings, if you use the old URL, the URL that you used to get into this, it won't work. So just be aware that you're going to need an updated Zoom URL with passcode, and I'll get that distributed and announced on the various Slack channels for next time. Just wanted to get that out, and Harry, over to you.
Okay, sounds good. Thank you, John. So I think Bhushan and Rama and Jackie just joined, and so I think Ashwani was here when we were talking about it. But basically, so far we covered 3 kind of sections of the roadmap discussion. And so one starting with kind of the horizontal plane, where we kind of talked about the ML pipeline and data processing and so forth. And then the second part was basically we talked about how things like op definition or IRs, which is considered to be somewhat vertical because it's kind of getting close to the hardware. And then the third discussion was around the core of ONNX. So we talked about model zoo, error handling, and then quantitation. So those are some of the topics that were covered, and I think that we had enough coverage in those 3 meetings. And so we thought that I actually didn't actively advertise this meeting, because we wanted to have a small group and then try to go through the features that were suggested now that we know, and try to do some impact analysis. And definitely the starting point was basically, as Prasad, if you could scroll down to the one that we were looking at before. This is kind of the roadmap document, and then towards the end, I just added a table that had the list of the features that community suggested. And then I only put steering committee's name here, but definitely we want to expand it. So we're talking about expanding so that we have a better tool. So it's not just five people just kind of voting, but we actually wanted to hear from the community which one they thought that was important. And so this is kind of the first iteration, and I kind of went through the features that I thought was pretty important. And this is actually quite coarse grain. We think that right now coarse grain analysis should be good enough to kind of get to the next stage, because I think doing something super detailed is not going to, it's going to be very time consuming. And so the high, medium, lows are basically indication of these are the things that are must have. So that's high, and then medium is good to have, and then low is something that we could have, but not at this moment. So that was kind of how I rated these things, impact analysis, and it is a bit of a gut check, but we wanted to spend the next 30 minutes discussing why some of these things were kind of rated high and so forth. So that was kind of what we were going to do. Any comments or questions before we get started?
So some of these topics are too generic. It's difficult to, like, for example, shape inference, it's rated high.
Right. Yeah, I couldn't. You're correct. So I thought about putting in what that actually meant, because there are 3 different things that were suggested, and I just didn't have. I guess I should break them into the specifics. But I thought that maybe in the document you can go back and refer it. But if you were to come up with actually a tool to do that, then we definitely need to break it down to more specifics.
Yeah, I think it's good, for example, for a few of these items or features, right? Like there are multiple things suggested. So for example, shape inference, we may not want each of them to be rated as high. For example, there is request for symbolic shape inference also. and other fixes to shape inference. So it would be good to, especially for topics like shape inference, which are pretty central and important to ONNX, it would be nice to break it down.
Yes, I agree with you. So I'll go back and do this again to make it more specific. Initially, when I was doing this, I was thinking that it'd be too much detail, but I think you're correct. So thanks for that suggestion.
Yeah, I mean, the other thing is, I guess it might also be helpful to understand the cost or effort, because I think some are fairly large scoped tasks, whereas some are probably not as significant. So
yeah, so that's a part that I didn't mention, which we actually talked about right before this meeting. And thank you for bringing that up. Basically, after this impact analysis, we were going to go back to the SIG leaders and then try to get the engineering cost estimated for each item. And so once you have the impact and cost analysis, then you can do at least a course grain prioritization. So that's kind of the thinking here.
okay.
Yeah, thank you, Rama. Okay, so I don't think that I'll be able to cover everything in 23 minutes, but I can at least get things started, and then, I mean, this is the first time that we are doing it like this, so suggestions are definitely welcome, because we want to make sure that the community voice is reflected here. And so, yeah, I can just get started, just kind of going these line by line, and why I thought it was important. But would that be a good way to handle it, or how I'm definitely open to suggestions.
I think get through as many as you can.
Okay.
I think, you know, it would be good to make sure that you do cover a couple lows as well as the highs. So yeah, just so we understand the point of view on it.
Yeah, sure. So the first entry is data frame support, and I think this is pretty crucial if you want to support. And I think this is also kind of tied to initiative that Sheng was driving on the PyData things too. But basically, having the data frame support, I think it will be tremendously valuable for data scientists to be able to use ONNX. And so that's why I rate it high. And this also has connection to the pre-processing. There has been requests for supporting pre-processing, and I feel like if we were to support all these different data types, then you might not necessarily have to support pre-processing. That's so you guys can kind of tell me whether that's a weird thinking, but basically there are many libraries that are out there that does pre-processing, and if you were to be able to read that pre-processed data, then I think that you should be able to support pre-processing using an external library that could be read into ONNX. And so it might solve both problems at the same time. That's kind of what I was thinking here.
And for the data frame support, are you seeing that needed for certain types of models more than others? Like vision models versus NLP or something?
Right. I think the suggestion, if you were to scroll up, I believe it was from, escapes my memory, but there are two implementations that they were suggesting. One was kind of grouping a sequence. Oh yeah, it's from Takuya, I think. Either having a tensor list or extending the sequence type. And so I guess to answer your question, I don't have a specifics actually, but I will definitely go back and look into it.
I mean, it's a question for anyone on the call, I guess. Like, for anyone who thinks that the data frame support is important, like, what kind of models are you wanting to use it with? Would be interesting to know.
I guess the data frame is mainly for support classical machine learning models.
Well, that's what I was wondering. Is it mostly classical, like traditional ML, or is it, you know, DNNs and other models?
Yeah. So that's my personal feeling. It's mainly for classical ML. And another feeling of mine is that we already have tensor types, and tensor list is just a bunch of tensors. Why do we still need tensor list? So from lower level perspective, we already have some sort of tensor list. We just put some tensors into the model.
We have sequence data type, right?
Yes.
And yeah.
Yeah, but I think that's different from what a data frame is. Data frame
Is heterogeneous.
Is more a heterogeneous collection of tensors, really. It's a collection of tensors. I mean, to some extent, you can do things like data frame by just flattening it out into a collection of tensors without having an explicit support. But if you do want to add a support, you could add a new type. But it's more like a tuple or a record or a table. It's not really sequence.
And also sequence right now is with the same data type. Data frame can have different data types.
Yeah. I think data frame is like a relational table, right? A database. It's like a collection of columns, really.
Exactly. The columns can have different types.
Exactly, and so it's different.
It's a record in a database. Yeah.
Yeah. It's different from sequence, I think. So.
No, it is definitely different from sequence. We need to go and look back how heterogeneous sequence is, but I don't think it is as flexible as a data frame can be. That said, in my opinion, also, it's mostly, I've not seen data frames too often in DNNs, mostly in traditional ML.
Yeah, that's right.
Yeah, that is correct. And I clearly didn't think there's this. So talking through this actually helps with assessing the importance. So
I think it'll be useful, like, for each of the features, probably for us to kind of articulate, like, what is this is a nice capability, but, like, what will it enable? Are we, going to be able to support new classes of models? Like, what type of classes of models are we going to be able to support? Will it make something easier or faster? And that might help us better evaluate kind of the ROI, depending, because there's also an engineering cost column that's going to be added at some point.
So when are we going to have that kind of estimate?
Basically, the thinking was that we wanted to spend maybe a week on getting the impact figured out, and then we have 2 additional sessions that are scheduled. But we wanted to reach out to the SIG leaders to kind of figure out the engineering costs. So that was kind of the thinking here.
Okay.
But yeah.
Yeah.
So I guess that will be good to have 1 line or 2 for each item as the ROI. So it's easier to see what is high versus low, right?
In the way that it's done, how would you implement it? I have a hard time seeing it through. Could you explain a bit more, Shin?
What I'm trying to say is once as a group we decide one feature as high, maybe want to provide a line or 2 to highlight why this is high, why this is low.
Mm-hmm. I see. Okay.
Right.
So more like a comment per box in there. Why you think it's high?
maybe it's collectively at the end.
Okay. I see. Okay. Okay. I'm already kind of seeing the holes in what I created in 5 minutes. And so thanks for your comments. Yeah.
So, yeah, one comment about the pre-processing. Yeah, I mean, you're talking about the pre-processing. Maybe I didn't fully understand it, but in the context of something like training, it is valuable to have all the necessary steps captured within an ONNX model, because rather than relying on some external libraries or something else to do pre-processing steps, if it's because it can have an impact on the performance in a training context. Right?
I think it's also useful on the inferencing side, especially if you're not inferencing in a Python environment. A lot of the libraries that people use for pre-processing traditionally are only available in Python.
Yes, yes. I think for
cross-platform very difficult.
Yep.
yeah. For inferencing, this is if you're not in a Python-based environment, then it's helpful.
And this might be related to the data frame as well, because some data may come in as data frame and then be processed or pre-processed before we feed the data into a model.
Yeah, I think they're related but separate. I mean, my understanding of the data frame is it's a new data type that we want to introduce. And
Yes,
then pre-processing needs to apply to various types of data. It could be a string, it could be a data frame, it could be whatever number.
Yeah, exactly. It's separate. I'm talking about is whether pre-processing is important.
Yeah,
I think it is because, right, you mentioned a few things. I'm talking about even you have data frame. A lot of times you use data frame in pre-processing.
Yep.
But pre-processing is hard to be standardized.
We will be hitting a lot of type-related scenarios with pre-processing. Data frames are kind of like symptomatic of that. There are heterogeneous data, how that gets processed into a tensor. That it's a big funnel in, right? So there's a lot of different types, different common types that people use. Pillow image library produces a certain type, and OpenCV decoder, JPEG decoders produce a certain type. Converting that to tensor, those could at least be standardized. If in general pre-processing, the universe of pre-processing will encompass all of those types. So it's a pretty big funnel in.
Yes.
So do you think that that's something that ONNX should support as a, because it seems super broad to support pre-processing at this stage. And so it seems pretty high engineering cost type of thing. And
yeah, it's too difficult.
Okay, see, that's the reason I wanted to know if engineering cost would be part of the decision to prioritize high versus low.
I guess it's not only about engineering costs. Like it's easy to standardize mathematical equations in deep learning models, but it's hard to standardize or even formulate the decoding process of JPEG files.
Yeah. Okay.
So that's
but maybe the key is, I mean, more than pre-processing, the question is what is missing in terms of operators or types, right? I mean, if something is missing and worth adding, right? Is it really a question about missing operators and types?
Yes, for the purpose of pre-processing.
But even if we consider operators for preprocessing, it's still hard, right? There are numerous amount of image format, and we need a lot of operators to cast images to tensors if we want to standardize preprocessing.
And it was also suggested in the document, I forget the name, but the pre-processing, some of the examples they wanted was audio spectrogram and fast Fourier transform. And so it was not just like a vision related processing either. And so, well, audio spectrum, I guess it's converting to image, but so the scope can be really broad, and figuring out which one to support, I guess that's also very difficult, I think.
Yeah, so I agree. It's a low priority.
Okay, but at least having this discussion actually really helps. So thank you guys so much for kind of going through the items and then participating in the discussion. So we'll definitely expand this column so that, or we'll try to come up with a tool where we can actually get your feedback on the impact analysis so that we can actually hear from you. So thank you. Okay, should we then move on to the next item? Is that okay, or should we? Are there more comments for the first 3 items?
Just one comment about pre-processing. I mean, like when we, let's say, introduce pre-processing, it's not that we need to support every data type out there. For example, OpenCV and something like that. If you have a standard that, okay, we support image to tensor conversion, basically we support image pre-processing. So we pick one format, let's say we support PIL image format, and then we basically provide all the utilities to process over those image. And now if user has, let's say, OpenCV or some other image format, they just have to pre-process it to PIL image, and after on, like there onwards, we support all the pre-processing that we can do in the image. So it's not that we need to support maybe all, but it's just that if we pick the high level category that these are the important areas that we might be useful for developers, and then we can just standardize on top of that. That's all. Thanks.
Okay. I think
I would largely agree with this. I mean, pre-processing, I think one way to approach this would be to figure out which are the heavy hitting ones, and then figure out on a case-to-case basis to standardize that. Maybe tokenization is a common pre-processing step for NLP models that can be standardized. But one thing to be careful about here also is that in a lot of these cases, this can be a big effort, because, for example, something like images getting resized is a pretty common pre-processing step. If you look at different libraries that resize images or interpolate images, there can be subtle edge case differences that can change the final outputs and make it different between these different libraries. And it's kind of a implementer's choice that shows up in all these cases. So something as benign as standardizing a image interpolation or image resize operation, in fact, sometimes even a very simple thing like image crop is also presents such situations. They can be deceptively they can be deceptive in how easy they seem, but when you end up standardizing that, it could go pretty deep. So I guess I agree that there may be a way forward here by kind of collecting common pre-processing steps and addressing them first. My comment is more on the engineering cost, that even simple things that seem very simple for pre-processing might take effort, significant effort to standardize.
I think Ganitra also mentioned in the document above that I think she wanted to consider the pre-processing for the models in the model zoo. So I think that kind of is shared with your sentiment. Yeah. I think I cut somebody off. Go ahead. Okay. Any more comments on the pre-processing?
No.
Okay. So if there is no more comments, then the end-to-end machine learning pipeline, I don't really want to rely on my personal choice anymore. So any comments here? Kind of my idea here was that there's so many other items that I thought it was so much higher impact at this point. And so that's why kind of it ended up on the lower spectrum, just in my personal opinion. But we'd love to hear from you from the community.
Yeah, I guess low priority is reasonable. End-to-end ML pipeline is as complicated as pre-processing and data frame. So
Right, and I think Chin, if I'm not mistaken, when you recommended this, I think you were talking about pre-processing as well as a part of the end-to-end, and that could be a starting point. So
this was really about just creating an example, right?
Right. Sorry, my memory is not as good as I thought. So sorry about that.
Chin, does this involve work other than kind of creating a sample using existing functionality?
This is to make ONNX in the end-to-end pipeline or environment, so people realize in which places, at which phases, ONNX can play a role. It's sort of example and also illustration of how ONNX can be applied in general. Yes.
Sure. I mean, I think that would be useful to do, but I mean, it doesn't really involve changes to ONNX itself. It's more like building end-to-end example or something like that. And also, but I don't think it's just ONNX, right? You would need to bring in other components like ONNX runtime, for example.
Exactly. Yes, we need to have ONNX runtime. Like you said earlier, if we have pre-processing with data frame, then we can have a more complex pipeline utilizing more ONNX. Otherwise, you can imagine we only deal with sort of the inference phase. Right?
Another idea might be that you could at least start a little bit smaller. And so maybe you could, because Chin, I know that you're working on training part, and basically if you were to allow ONNX to kind of be fine-tuned, and then maybe apply quantization afterwards, then that could be one component that you can start with, and then you can gradually expand out of that kind of compute cycle. That's what I was thinking.
Yeah, yes. So as you can imagine, there will be multiple phases or stages. The last one is the inference, what we can do right now. Once our training becomes more mature and ready, and then we can add another piece into the pipeline using ONNX. Once we have pre-processing, we can have another one, right? So eventually the goal is to be able to do multiple phases using ONNX. Okay, like you said, we could do this from very end right now, and slowly we add more coverage.
I see.
Yeah.
Okay, so if you were to start on something for this end-to-end machine learning pipeline, then what would be the immediate first step? What would be your recommendation?
Well, that's something I asked earlier. If the engineering effort is part of this equation, if it is, then I'll have to go back and do some more research and see how much and what we might need to do to get this realized. I think it's the same for the other items, right? Eventually, if you say go or no go, you want to know who can commit how much effort is needed.
I see. Okay. Okay. We're actually approaching the end of the hour, or top of the hour. So this discussion was really helpful, but I don't think that we'll be able to actually get through all the items. Unfortunately, we only scratched the surface of it. So we'll try to come up with a tool to facilitate this discussion even further, and not just have 5 columns, but have everybody contribute to the importance of or the impact analysis of this. So we'll follow up. So please look out. We'll try to post it on social media and as well as probably on the ONNX website as well. But thank you so much for your discussion. Any comments before we go?
Thanks, Harry, and thanks for everyone for joining.